Hi everyone, in this video we look at how to simplify rationals and how to perform arithmetic operations involving rationals. So here we're asked to simplify fully. So the first thing that I'm going to ask you to always do is always see if you can simplify any radicals before you do any operations. So root 3 can't be simplified and root 6 can't be simplified. So remember, a fundamental property of multiplication is that multiplication is both associative and it's commutative. So we can rewrite this product as 2 times 3, which is 6, times root 3 times 6. Now root 3 times 6 can be written as root of 3 times 6. Now if I think about this, 3 times 6 can be rewritten as 3 times 3 times 2, or 9 times 2. So I can write this as the square root of 9 times the square root of 2. The square root of 9 is just 3. So I've got 6 times 3, which is 18, and this simplifies to 18 root 2. Next, we've got binomial times or 4 plus 5 root 3 times 2 root 3. So I need to distribute 2 root 3 into the brackets here. So both of these numbers are going to be multiplied by 2 root 3 since I can't add 5 root 3 to 4. So the first thing that I'm going to do is I'm going to multiply, I'll multiply 4 by 2 root 3. 4 times 2 root 3 is the same as 4 times 2 times root 3, which is 8 root 3. And then I can multiply 2 root 3 times 5 root 3. Well, 2 times 5 is 10. And then I have root 3 times root 3. So I have 10 times root 3 times root 3 is just 3. So I'll have 10 times 3. And this simplifies to 8 root 3 plus 30. So in the next step, in the next example, we're asked to multiply root 3 plus 5 times 2 minus root 3. So here it might be tempting to try to add root 3 and 5, but you can't, or subtract root 3 from 2, but you can't if you want to keep it in exact form. So I actually need to expand these and treat these as though they're binomials. So first I'm going to multiply root 3 times 2, and then I'll do root 3 times negative root 3, followed by 5 times 2, and 5 times negative root 3. So let's do root 3 times 2 first. So I get that this is equal to root 3 times 2 is just 2 root 3. And then I've got root 3 times negative root 3, which is minus 3, because root 3 times root 3 is 3, and since I'm multiplying a positive and negative, I get minus root 3, or minus 3. Then I'll do 5 times 2, which is positive 10, and then 5 times negative root 3, which is minus 5 root 3. So now I've got, let's see what I've got here. I've got 2 times the square root of 3 minus 5 root 3. So I've got 2 root 3's minus 5 root 3's, which simplifies to minus 3 root 3. And then I have negative 3 plus 10, which is positive 7. So this simplifies to minus 3 root 3 plus 7. If you want to write it so that you have a positive number first, you can write this as 7 minus 3 root 3. And then it just looks a little bit nicer. Lastly, in D, we have root 8 minus root 3 times 2 root 2 plus root 3. So the first thing to do here is we can simplify root 8. We can look to reduce any radicals, just to see if we can make our life a little bit easier. So the square root of 8 can be written as 2 root 2. So we'll have 2 root 2 minus root 3 times 2 root 2 plus root 3. Now we could expand this using FOIL, but notice that it's in the form of a plus b times a minus b. So we're actually multiplying two conjugates here. So this is equal to a squared minus b squared. So if I square 2 root 2, I get 2 squared times root 2 squared, which is 8. If I square, and I have to subtract from that root 3 squared, which is just 3. So this is equal to 8 minus 3, which is 5. So sometimes if you look for, if you have a product like this and you see that you're multiplying two conjugates, it's faster to identify that it just expands to a difference of squares. Lastly, I wanted to address a misconception when you're expanding radicals. If you have root 2 minus root 3 squared, a really common mistake is just to do this, just to say that this is 2 minus 3. But if we think about it, when we're expanding a plus b squared, or a minus b squared, let's do a minus b squared because it matches this question that we're doing a little bit better. So if you expand a minus b squared, you'd actually get a squared minus 2ab plus b squared. So there's a middle term. So I can't just do 2 minus 3. That would be incorrect. So I'll do, using this identity that I've been given, I can just square a. A is root 2. If I square root 2, I get 2. Next, I can do minus 2ab. So I'll get minus 2 root 2 times root 3. And lastly, I have plus b squared. So I'll have plus root 3 squared, which is just 3. So now I can add 2 plus 3 is 5. And I have 5 minus 2 root 6. So you can see that if you use these identities, it makes your life a little bit easier in a lot of cases. So that concludes this part of the lesson, and we'll see you in the next video.